Myself, P. Saradabalan, Assistant Professor, Department of Civil Engineering, Rohini College of Engineering and Technology. So, today's subject is engineering mechanics. So, first one, the mechanics concept and applied mechanics. The branch of physical science that deals with the state of rest or the state of the motion is termed as mechanics. Starting from the analysis of rigid bodies under gravitational force and simple applied forces, the mechanics has growth to the analysis of robotics, aircraft, spacecraft, and the dynamic forces, atmospheric forces, temperature forces, etc. The mechanics is developed by researchers, may be grouped as classical machine mechanics, relativistic mechanics, wave mechanics. In classification of mechanics, based on the body to which mechanics is applied, the engineering mechanics is classified as mechanics of solids and the mechanics of fluids. The solid mechanics is further classified as the mechanics, rigid bodies and mechanics of deformable bodies. The body which will not deform or the body in which deformation can be neglected in the analysis are called as rigid bodies. The mechanics of rigid bodies dealing with the bodies at rest in termed as statics, and that dealing with the bodies in motion is called dynamics. The dynamics dealing with the problem without referring to the forces causing the motion of the body is termed as kinematics. And if it deals with the forces causing motion also is called as kinetics. Basic terminologies in mechanics. First one is mass. The quantity of the matter possessed by a body is called mass. When a body is taken out in a aircraft, the mass will not change, but its weight may change due to change in gravitational force. Next one, time. Time is the measure of succession of events. The successive event selected is the rotation of Earth about its own axis, and this is called the day. Next one is space. The geometric region in which study of body is involved is called spaces. Next one, displacement. The displacement is defined as the distance moved by a body particle in the specified direction. Next one, velocity. The rate of change of displacement with respect to time is defined as velocity. Next one, acceleration. Acceleration is the rate of change of velocity with respect to time. Thus, A is equal to dv divided by dt, where v is the velocity and t is the time. Next one is momentum. The product of mass and velocity is called momentum. The momentum is equal to mass into velocity. Next one is rigid body. The body is said to be rigid if the relative position of any two particles in it do not change under the action of the forces. So next topic is law of mechanics. The law of mechanics, the following are the fundamental laws of mechanics. First one, Newton's first law. Second one, Newton's second law. Third one, Newton's third law. Fourth one, Newton's law of gravitation. Fifth one, law of transmissibility of forces. And the final one, parallelogram law of forces. First one, Newton's first law. It states that every body continues in its state of rest or uniform motion in a straight line unless it is compelled by an external agency acting on it. This leads to the definition of force as the external agency which changes or tends to change the state of rest or uniform linear motion of the body. Newton's second law. It states that the rate of change of momentum of a body is directly proportional to the embraced force and it take place in the direction of the force acting on it. Thus, according to this law, force proportional mass in the acceleration. Therefore, the F is proportional mass in the acceleration. And Newton's third law, it states that every action there is an equal and opposite direction. Consider two bodies in contact with each other. Let one body applies a force F on another. According to this law, the second body develops a reactive force R which is equal in magnitude to force F and act in the line same as F but in the opposite direction. Newton's law of gravitation. Every body attracts the other body. The force of attraction between any two bodies is directly proportional to their masses and inversely proportional to the square of the distance between them. According to this law, the force of attraction between the bodies of mass m1 and m2 at a distance d as shown in figure. So F is equal to G into m1 m2 divided by d square. Next, law of transmissibility of force. According to this law, the state of rest or motion of the rigid body and unaltered if a force acting on the body is replaced by another force of the same magnitude and direction but acting anywhere on the body along the line of action of the replaced force. Next one is parallelogram law of forces. The parallelogram law of forces enables us to determine the single force called resultant force. This law states that if two forces acting simultaneously on a body at a point are presented in magnitude and direction by the two adjacent sides of a parallelogram. The resultant is represented in magnitude and direction by the diagonal of the parallelogram which passes through the point of intersection of the two sides representing the forces. Next, units. Length, mass, time are the fundamental units in mechanics. The units of all other quantities may be expressed in terms of these basic units. The three commonly used systems in engineering are meter, kilogram, second system, centimeter, gram, second system, foot, pound, second system. That is, the following units are area is equal to square meter that is the notation of m square. The volume, that is the unit is cubic meter, and the notation is m cube. Velocity meter per second, that is the notation is meter per second. Acceleration meter per second per second, so that is the notation of the meter per second square. Thank you.